Okay, today we're gonna do a few examples of solving rational equations. So, rational equations are just anything with fractions like this. And this first example that we're gonna work on here is gonna look just like this. And um, we're gonna solve it using the cross multiplication method. So, um, when you have a rational equation like this, you can use a little trick called cross multiplication. And what it does is it pretty much gets rid of your fractions for you. So cross multiplication means that you're going to be taking your bottom term here, x minus 2, and multiplying it with your top term on the other side, x plus 4. And then same thing with your bottom term, x minus 5 here, and your x plus 3 there. So we're going to be taking x minus 2 times x plus 4, x minus 2 times x plus 4. So that's this cross here. And then we're going to be setting that equal to our other cross, which is x minus 5 times x plus 3. And the reason why this trick is nice is because now we don't have any more fractions. Because our number one goal when we're solving anything with a fraction is to get rid of our fractions first and then continue to solve our equation like normal. So I'm going to make a video going into why this cross multiplication works out nicely. So stay tuned for that if you are interested. But we're just going to solve this problem really quick to get some good practice in. So now I have two terms that are being multiplied together, and I'm going to have to FOIL them out. So I'm going to just FOIL the left hand side. So first term is x times x, which is x squared. Outside term is x times 4, which is plus 4x. Inside is going to be negative 2 times x, so negative 2x. And then last is negative 2 and 4, so we're going to get minus 8. And then that's going to be equal to this right hand side also FOILed out. So x times x gives us an x squared. X times 3 gives us plus 3x. Negative 5 and x gives us minus 5x. And negative 5 and 3 is going to give us minus 15. So now that we have this, we want to combine these inside terms. So we want to combine these two terms together and these two terms together. So I'm going to have x squared, and then a 4x minus a 2x is going to give us plus 2x, and then minus 8. And that's going to be equal to x squared. And then we have 3x minus 5x is going to give us minus 2x, and then minus 15. So now we can see that we have two quadratics equaling each other. So we can just solve this like a normal quadratic equation, and we're going to want to move all of our terms onto one side, and then odds are we're going to have to factor something. We got kind of lucky with this case because when we go to move one of our x squares over, it's going to end up canceling out. So let's just move everything over onto the left hand side. So if I subtract x squared from both sides, these just are going to end up canceling, and now we're left with a linear equation, so that's nice. I'm going to move these two terms over as well. So I'm going to add 2x and add 15. And what we're going to be left with is, well, 2x and 2x is 4x, and negative 8 and 15 is going to give us plus 7, and that's going to be equal to 0 because all of these canceled out over here. So now we can just solve this like a normal linear equation. So we're going to have 4x equals -7, and then we want to divide both sides by 4 to get rid of the 4 on the x. So we're going to do just that, and these are going to cancel there, so we have x equals -7 over 4. So that's going to be our final solution. Now, one thing that's important to do when you're solving rational equations is to plug your answer back in and make sure that you don't create a 0 somewhere in the denominator. Having a 0 in the denominator is not allowed, so if we plug this -7 over 4 back in for x in our denominator here, we need to make sure that we don't create a 0 in our denominator. So -7/4 minus 2 is not 0, and -7/4 minus 5 is also not 0. So it looks like in this case we're good. But always make sure to plug your answer back in to your denominators here, just to make sure that you don't end up with a solution that gives you a 0 down in the denominator. So that's the first example. In the next video we're going to be doing this problem right here, and we're going to use the same technique. We're going to use cross multiplication, only when we get down to here our x squareds aren't going to cancel out. So we're going to get down to here where we have kind of a big mess of terms, and when we go to move everything over onto one side of the equation, we're not going to get our squared terms to cancel, so we're going to have to solve something that is a quadratic rather than linear. So stay tuned for that.